Hello everyone, this is our last unit review video. So this is over unit 6 and 7, which is Inference. So this week I'm sharing with you this AP Stat recap page. This is a paper I made a couple years ago that kind of summarizes everything that we've done this year. So on the front, you see everything from units 1 through 5. I'm not going to go over all of this with you now. You can review it all in the other videos. But this is really helpful when you're studying. You're obviously allowed to use this as much as you need when studying. You are not allowed to use it when you take the actual exam. Notice I left some space between the different kinds of graphs for you to draw a little example. You can also highlight titles, underline things, whatever you want to do, add your other little notes. But I think that this is really useful in kind of putting everything on one page. On the back, or the second page if you can't print two-sided, is Inference. So there's some empty space on this one because I took off the chi-square test since that won't be on your AP test this year. And I just have the different types of inference that will be on the test, specifically 1 proportion z-test, 2 proportion z-test, 1 sample t-test, and 2 sample t-test. So what I have here, I have the name of the procedure. I have how the hypotheses are written. Don't forget to define your parameter like that. And then I have the assumptions. Remember, for all of these, there are 2 assumptions. Random, so either random sample or random samples or random treatments. That is a really important distinction. If it's treatments and you say random samples on the AP exam, you will not get credit for that assumption, which you know knocks you down to at least a partially correct, which means the highest you can get is a 3. But if you get another partially correct, the highest you can get is a 2. So make sure you're using the correct thing. So we have randomness, and then the other one is normality. With proportions, we have to check that n times p and n times 1 minus p are both greater than or equal to 10. Remember, for 1 proportion, we use p hat for confidence interval assumptions and p for hypothesis test assumptions. When we do 2 proportion, you can actually use 5 or 10 here. So I said it there, but really all of them are 5 or 10. You can I've been consistently using 10 nowadays, but you can do whichever one you want. And then these will actually end up being p hats because you don't know what p is, so you have to use p hat. But you'll have to check it for both proportions, so there will be 4 things you have to write out. For means, you have 3 options to check for normality. It can be given in the question. Our sample size can be greater than 30. Or we look at the graph. We use the normal probability plot if we have to make one, but most likely if it comes up on the AP test, you won't make one. They will give you a graph and then you talk about their graph. So they're not gonna, most likely you are not going to be making a graph, especially since we're doing it on the computer this year, but they might give you the graph and then you comment on their graph. If it's a histogram, you can comment on it being normal. If it's a dot plot, you might or might not be able to. Stem plot, you would be able to comment on normality. Box plot, or potentially one of the other graphs, you might only see symmetry. But symmetry is enough with the normal distribution. So if you have a box plot or something and it's symmetrical, but you can't really discern a normal shape because there's not enough data, or a box plot you never can, then it's still fine. So with 1 sample, there will be 1 graph, 2 sample, there will be 2 different graphs. They should give you both. Or the sample size is greater than 30, or even 15 is sometimes used for 2 sample, but not for 1 sample. And then for your calculations, it's all done in the calculator as long as you write the name You don't have to show the work. So make sure you write the name of your procedure, your hypotheses, your assumptions, and then these are the numbers you need for your calculations. Remember, alpha is 0.05 unless otherwise stated. And that's true for all of the tests. Make sure when you write your conclusion statement for the two means or the two proportions that you define which way you're subtracting. This is 98% chance this is not going to happen. If we know the population standard deviation, then we would use actually a z-test instead of a t-test. This is very unlikely though. For matched pairs, remember this is when you have a dependent sample. This could be before and after. It could be like two paired individuals, twins, a married couple, anything where it's two that are dependent, that would be the same. Versus when you do a two-sample t-test, the samples need to be independent or the treatments need to be randomly assigned, completely randomized design. No, there's no pairing of any sort in the treatment. All of that can be reviewed in the other videos that were posted before. So the steps that you're going to do, if they ask you to make a confidence interval, you automatically have to do all three of these steps. They might say make and interpret an interval. They also want you to write the assumptions unless they explicitly say assumptions or conditions have already been checked. So anytime you do a confidence or hypothesis, you do all of the steps unless they explicitly tell you that one of the steps has already been fulfilled. So the first step is the interval name and the assumptions. They're written together because they're scored together. So make sure you have the name and the assumptions, your calculations, and your conclusion. For hypotheses, it's the same thing, except we have our hypotheses as our second step. So you do all steps unless otherwise stated. Our conclusion for our hypothesis test, we've been doing this long enough. I hope you know it by now. If not, you definitely need to know it before the day of the test. Since the p-value is, say it's less than A, we reject HO. There is sufficient evidence to suggest. And then you write HA or the question in context. Or if the p-value is greater than A, we fail to reject HO. There is not sufficient evidence to suggest whatever HA is. Let's see if I have highlighters. Okay, this would be a great place for your highlighters. I don't have highlighters, just pens. But we have our less than, reject, is, greater than, fail to reject, and there is not. So the italicized and the bold should tell you, but if you have a hard time discerning that, then I would pull out the highlighter. Your conclusion for your confidence interval, we are 95% confident or whatever percent confident that the population proportion mean, proportion 1 minus proportion 2, mean 1 minus, it's misspelled, mean 1 minus population mean 2. Yeah, that should be there. Really, population should be here too. Of context is between lower bound and upper bound. Our confidence level interpretation Should never mention the specific interval or the sample mean / proportion. This is just an interpretation of what does the 95% or whatever percentage it is, what does that mean? So in repeated samplings of the same size, confidence level percent of the intervals constructed will contain the population mean of context or proportion of context. Your p-value is the probability you get your sample or something more extreme if the null is true. To find the minimum sample size with one proportion, we use this equation. Remember, to get z star, you do inverse norm and you have to add the tail to that value. We use 0.5 for p unless otherwise stated. This is when we're trying to find the minimum sample size. They might ask you other questions that have to do with the margin of error. You just fill in the numbers that they give you and solve for whatever's missing. Same thing with two proportions, except we have the two separate fractions. We still use 0.5 for both fractions. For a problem like that, n1 and n2 are going to be equal. So n1 and n2 are going to be the same. You're going to be able to add the fractions. Remember not to add the denominators, you only add the numerators. To find the minimum sample size with one mean, we use this margin of error formula. Remember, sigma is the population standard deviation. The most likely one you're going to need on this list is this formula here, especially since there's no MC this year. And then last but not least, we have our errors. So if HO is true, so this right here is reality. And this part here is the decision that you make. That would have been better moved over a little bit. So your decision, so if you decide to reject HO, and HO is true, that was the wrong choice, specifically that's a type 1 error, which is alpha. If you reject HO, but HO was really false, that was correct, that's also the power of the test. If you decide to fail to reject HO and HO is true, that's correct. You said HO could be true, HO is true, that's good. If you fail to reject HO and HO is false, that was the wrong choice. Specifically, that was type 2, which is beta. When alpha, n, and the difference from the null increases, beta decreases and power increases. But remember, alpha is independent. So if you change n, that doesn't affect alpha. It only changes, alpha only changes if you change it. There's even some extra space over here if you want to add a few more notes. This is, I stretched things out because I had the chi-squared test on here before. In the next video, I'm going to look, I'll do it in this video. So this is not really necessary to watch if you already are really comfortable with hypothesis testing. But what I've done is I have found an example for each of the types of hypothesis tests, and I've put them on this second document. I'm going to post my answer key like this. I'm also going to post a blank copy if you want to do it. I don't feel like it's necessary, but if you want extra practice, it would definitely be helpful. But I don't think it's necessary. It's not part of the required curriculum. You can even print out my answer key if you want so that you can just see what an example for each type of hypothesis test looks like. Now, don't forget the hypothesis test is also, or there's hypothesis test, but there's also confidence intervals. I didn't write out a confidence interval example for each one. Assumptions work the same way, but they're, you know, you have different conclusion and all of that. It doesn't hurt to practice. There are lots of examples for you to look at. I do want to talk about how to type in a couple of these. So I'm not going to go over everything, but I'm going to go over a couple of things here and there. I would definitely recommend that you read over this and you look at everything, but I'm going to go over just a few things. So on this one, suppose a researcher surveyed 750 people to test this claim and he found 33% regularly take a multivitamin. So our p hat in this case, our sample proportion is 0.33. If we were using an equation, we can type in 0.33 and you're still welcome to use the equation. But it's not really necessary. Instead, you need to turn 0.33 into a fraction. Because remember, when you type it in the calculator, you're typing an x and you're typing an n. It has to be written as a fraction before you can type it in that way. So 0.33 is going to be x over 750. So x is going to be 0.33 times 750, which is 247.5. But we could not have possibly gotten 247.5, so you round that to the nearest whole number, which can be up or down. If this was 247.4, it would be just 247. I'm not predicting a future sample size. When I do that, when I'm trying to figure out what sample size I should use in the future, I always round up. But since I'm in the present and I've already taken the sample, I would just round whichever direction is appropriate. So when I type this in, go to stat, tests, 1 proportion z-test. Oh, I even already have it typed in. So I type in 0.37 for my p. I type in the 388 for x, right here. No. Oh, it just happens to be the same number. 0.37. This is 248. And 750. And then I want p to be less than 0.37. So this is p0, so I want p to be less than 0.37. And then I calculate to get my z and my p-value. And alpha is, of course, 0.05. I don't think there's anything special. Just read over this example. Here I worked out an example where we found the minimum sample size. There are lots of different things you can do with this margin of error formula. With means, so this is stat. This is a 1 sample t-test with means, but the calculator just says t-test. So when it says just t-test, it means 1 sample t-test with means. It gives you the option for data, which is when you have your data typed into a list, or stats. Most likely on the AP test, they might give you the data, they might not, but they'll also give you the mean. They'll give you the stats to make sure to give it less of a chance that you mistype something. So you always want to use the stats if you have them. So I would type in 38 here, and then I would find my sample mean was 39.7188. The standard deviation of 3.5476, sample size of 40, and then I wanted greater than. So there I get my t and my p-value. Degrees of freedom, remember, is n-1 for the 1 sample t-test. I think you can figure all of this out. Remember to watch out for an experiment. Over here, I have a matched pairs. So this was matched pairs. So we have 2 samples, kind of. We have online prices and local prices, but they're for the same customer. So he randomly selected profiles of 10 of his clients. So it would be an SRS of 10 clients. Or it would be a random sample. So yeah, a random sample of clients, and they're dependent because it's the same clients, local and online information. If it were 10 different clients for local and 10 different ones for online, then it would be a 2 sample t-test. But because it's the same customer and we're comparing their local and online, it makes it a matched pairs, which is a 1 sample t-test. So they're going to give you both graphs usually when that happens. I know that's kind of blurry, but you can see it if you pull up the document. They're going to give you both the individual graphs and the combined graph to make sure you know which one to use. So make sure it's very clear you're using the differences graph for matched pairs. When you type it into the calculator, you're going to use the price difference numbers as well. Don't type this in. There's no need to type in this table. I did greater than 0 here because I want to know if the local price is higher than the online price. So since they did local minus online, that was given up here, and I want local to be higher, that means I want the difference to be greater than 0. So that was just a brief overview of this page. Look at it in more detail. Email me or come to office hours if you have any questions. Good luck on your FRQ packet and your FRQ quiz this week.